If a clinic offered you 30 million stem cells to fix a nagging knee injury, and then another clinic offered you 100 million stem cells for the exact same price, I mean, you would choose the 100 million, right?
Oh, absolutely. Yeah, it's just completely human nature.
Exactly. We are so conditioned as consumers to just believe that more is intrinsically better.
Yeah.
Like more horsepower in a car.
Right. More gigabytes on your phone, extra strength medicine, all of that.
Yeah, exactly. But the thing is, when we get into the world of regenerative medicine, applying that basic, consumer math is a massive, potentially really dangerous illusion.
It truly is. I mean, you see this staggering number advertised on a billboard, and your brain just automatically fills in the blanks, you know?
Yeah, totally.
We equate a larger quantity with a more powerful treatment, and then we just assume, well, more powerful treatment guarantees a better clinical outcome. But biology doesn't really negotiate with billboard advertising.
Which is exactly why we are here.
Welcome to STEMCIERGE, your global concierge for advanced regenerative medicine. Here, we explore the science and breakthroughs redefining longevity and human performance, giving you clarity, confidence, and trusted insights as you navigate stem cell therapy around the world. Let's begin our deep dive.
So, welcome to today's deep dive. Today, we are looking at this incredibly insightful patient decision guide. And it's actually an interactive tool as well by STEMCIERGE.
Yeah, it's a great resource.
It is. And for you listening right now, our mission today is to really cut through the heavy information overload of medical marketing.
Because there is a lot of it out there.
Oh, so much. We are going to figure out the biological realities of why a massive cell payload might actually perform, worse than a smaller targeted one.
Right.
And by the end of this, you're going to be equipped with the exact framework to compare treatment proposals effectively.
And as we navigate this, I kind of want you to picture the backdrop behind me right now. Just imagine a high-tech medical research library.
Okay, I'm picturing it.
But instead of books, the shelves are filled with these glowing, interconnected data points, and each one represents a different cellular variable.
Oh, that's a cool way to look at it.
Because as we're about to see, raw quantity is just one single, sometimes really misleading dot in this vast biological constellation.
Okay, let's unpack this. We have to start with the allure of the big number itself, right? Because to understand why a glossy brochure boasting this huge cell count is so effective at fooling us, we have to totally redefine what a dose actually means in regenerative medicine.
Yeah, because it's not what people think.
Right. We aren't talking about a chemical compound like aspirin here. We're
What?
talking about living biology.
Exactly. The whole concept of a dose changes completely when the therapeutic agent is alive. Let's take MSCs, mesenchymal stromal cells, which are the primary regenerative cells we're talking about today. A raw head count of MSCs in a syringe is just a totally incomplete metric.
So what should we be looking at instead?
Well, to truly evaluate a proposed treatment, you have to separate three crucial distinct measurements. You've got cell count, viability, and potency.
And just to be super clear here, when a clinic is throwing around a big number on their website, they're usually only talking about that first one, right? The cell count.
Almost exclusively, yeah. I mean, cell count simply asks, how many biological entities are in this container? It's just pure quantity.
All right.
Viability, however, asks a much more critical question. It asks, how many of those specific cells are actually alive at the exact moment they enter your body?
Wow. Yeah, that's a huge distinction.
Right. And then potency asks the ultimate question. Do these surviving cells actually demonstrate the specific biological activity required to perform their intended function?
Let me try to translate this into something every day for you listening. It feels a lot like buying a bag of coffee beans.
Oh, I like that. Let's hear it.
So if I go to the store, the cell count is the total number of beans in the bag. 1 million beans. That sounds great on the packaging, right?
Right, sounds like a lot of coffee.
Yeah, but the viability is how many of those beans aren't completely stale, dried out, or just, spoiled from sitting in some warehouse for months.
It's excellent.
And then the potency is how much actual caffeine and flavor those specific intact beans are going to produce when I actually brew them.
That is a perfect analogy.
Because if I buy a massive bag of totally stale, poorly roasted coffee beans, I am not going to get a better morning cup than if I just bought a small handful of perfectly roasted, high-quality beans.
It's so true. The raw count just does not establish quality, and it certainly does not guarantee effectiveness. A massive bag of stale beans does nothing for your energy levels.
Yeah, exactly.
And if we look at how actual highly regulated medicine handles this, the source points to a product called RyoNCL.
I saw that in the guide.
Yeah, so this is an FDA-approved mesenchymal stromal cell therapy in the U.S., and it's used for a very specific pediatric form of graft versus host disease.
And I noticed in the source, the FDA label for RILNCL doesn't just say, give the patient 50 million cells. It is incredibly specific.
Right. It is not marketed as a flat, arbitrary payload at all. The label precisely defines the dose as 2 million MSCs per kilogram of patient body weight per infusion.
Wow, so it's totally customized to the patient's weight.
Yes. It is an exact, mathematically scaled biological product with a defined schedule. The manufacturer has characterized exactly what those cells do, how many are alive, and how potent they are.
Which is, light years away from a local clinic just flashing a flat, massive number for whatever happens to be bothering your knee or your shoulder.
Light years away, yeah.
So let's kind of transition from theory to actual human trials here.
Yeah.
Because if viability and potency matter so much more, what happens when researchers actually test escalating doses in a clinical setting?
Well, this is where the whole narrative of more is better just completely shatters.
Really?
Yeah. The source highlights the Lomo Espinosa trial. In this one, researchers tested 10 million, 40 million, and 100 million autologous bone marrow MSCs, and these were injected directly into the knee to treat osteoarthritis.
But surely there's a distinct scaling of benefit there, right?
Mm-hmm.
Logically, the group getting the absolute highest payload, the 100 million, should have drastically outperformed the group getting a tenth of that amount.
You would naturally assume that, especially based on clinic marketing, but the researchers found that the long-term clinical outcomes were actually quite similar across all three of those doses.
Wait, quite similar?
Yeah. The massive high-density dose did not drastically outperform the lowest dose at all.
Okay, so they basically tied. But wait, if we look at the Gupta trial, the results don't just plateau, they actually go backward.
Yeah, that's right.
Because in that trial, they scaled from 25 million to 50 million to 75 million, all the way up to 150 million cells. Do we see diminishing returns there or actual negative returns?
We see the trend reverse. In the Gupta trial, the strongest trend for clinical improvement was actually observed in the lowest dose group, the 25 million cohort.
That is wild.
Yeah, the higher payloads did not clearly outperform it. And actually, across certain metrics, they fared worse.
How does the biology of that actually work? How can delivering a smaller number of regenerative cells to an injured joint do a better job than a massive influx of them?
It comes down to a really crucial concept known as the therapeutic window. You have to understand the environment you are treating.
Okay, explain that a bit more.
So a joint capsule, like a knee, is essentially a closed ecosystem. It has a very specific, limited supply of oxygen and nutrients, and that's because it does not have a massive high-flow blood supply running directly through the center of it.
Oh, I see. So it's not like the bloodstream where resources are constantly circulating at high speeds.
Exactly. Think of the joint capsule like a small, carefully balanced aquarium.
Okay, an aquarium.
If you put 5 fish into a small tank, they have plenty of oxygen, plenty of food, and they just thrive.
Makes sense.
But if you cram 150 fish into that exact same small tank, they instantly consume all the available oxygen. They foul the water, they suffocate.
Oh, wow. That is a dark image, but I get it.
It's the exact same thing with cells. If you overpopulate a joint capsule, those cells are suddenly competing for really scarce oxygen and nutrients. They enter a state of hypoxia, they become stressed, they starve, and ultimately they die.
That paints a very clear picture. And the data from global trials seems to really back up this aquarium metaphor.
It absolutely does.
Yeah, because the source brings up a major 2026 network meta-analysis by Xi and colleagues. They looked at 11 randomized trials involving over 600 participants. And they categorized the doses, right?
Right.
Low was under 20 million, moderate was 20 to 50 million, and high was anything over 50 million.
And the findings there were just fascinating. They discovered that the moderate doses, that 20 to 50 million range, actually ranked best for several long-term outcomes.
And the high doses.
The higher doses, anything over 50 million, they performed slightly better for some initial short-term outcomes, but they did not hold the crown for long-term joint repair and pain relief.
Okay, so understanding that cramming too many cells into a space just leads to starvation, that's one thing. But I want to really push on this. Does overshooting that therapeutic window just mean you waste your money on cells that die? Or can it actually cause active physiological harm to the patient?
It can absolutely cause active harm. And the 2024 MATAS trial illustrates the biological mechanism behind this perfectly.
Okay, what happened in that one?
In this study, patients received either 2 million, 20 million, or 80 million umbilical cord MSCs for knee osteoarthritis. Now, crucially, all of these different doses were suspended in the exact same 3 milliliter injection volume.
Okay, hold on. 3 milliliters is tiny. That is barely more than half a teaspoon of liquid.
Right.
Packing 80 million biological entities into half a teaspoon versus just 2 million, the physical density of that is completely different.
It is an extreme density difference, and the biological environment reacted exactly as you would expect. While all the groups showed some improvement from their baseline, every single patient in the 80 million group experienced injection-related knee swelling.
Wow, every single one. Was that because of the hypoxia you mentioned earlier?
Precisely. When you cram that many cells into a small, closed space, a massive percentage of them immediately suffocate and die.
And then what happens to them?
Well, when cells die, they don't just magically disappear, they turn into cellular debris. The body's immune system detects this sudden graveyard of dead cells and immediately dispatches macrophages, which are basically cleanup cells, to clear the debris.
Right, makes sense.
But this immune response triggers localized inflammation, which pulls in fluid. And that is the severe swelling those patients experienced.
Wow.
The lower and moderate dose groups in that trial actually produced greater long-term improvements without triggering that adverse inflammatory swelling.
What's fascinating here is we're seeing concrete proof that more is better is just a total fallacy. The highest dose triggered an immune response against dead cells rather than a regenerative response from living ones. But I imagine we have to be careful not to swing the pendulum entirely in the other direction, right? If 20 million works in a knee, can we just declare 20 million the magic universal number for everything?
No, we definitely cannot. And doing that would just be another oversimplification. The optimal payload depends entirely on the specific organ, the condition, and the biological environment you are targeting.
Okay, give me an example of that.
The source provides a brilliant contrast to the knee trials by highlighting the Trident trial. This was a study looking at ischemic cardiomyopathy, which is a really severe heart condition.
Right.
They delivered allogeneic MSCs directly into the heart tissue, and they tested a 20 million cell payload against a 100 million cell payload.
And let me guess, the heart responded differently than the knee.
It did. In the Trident trial, the 100 million cell group showed significant improvements in ejection fraction, which is a key measure of the heart's pumping ability. The 20 million group did not show that same level of improvement.
Wait, why the reversal? How does the heart survive that massive payload without triggering the same suffocating effect we just saw in the knee?
Because of vascularity. The heart is arguably the most blood-rich, highly oxygenated environment in the human body.
Oh, right, it's pumping blood constantly.
Exactly. It can biologically sustain the metabolic demands of 100 million introduced cells in a way that an isolated, low blood flow joint capsule simply cannot. Different environment, different capacity, entirely different result.
Context is king. You cannot take the biological blueprint for a heart and just apply it to a knee.
No, you can't.
Which brings us to the next massive piece of the puzzle here. If the therapeutic window shifts entirely depending on the condition, what are the specific variables you, the listener, need to scrutinize when looking at a treatment proposal?
Just a quick break. This episode is brought to you by STEMCIERGE. If you're exploring stem cell therapy or evaluating clinics around the world, visit STEMCIERGE.com and take the free quiz to receive your personalized assessment. You'll get expert feedback on your eligibility, treatment options, and potential destinations, empowering you to make informed, confident decisions in the world of regenerative medicine. Visit STEMCIERGE.com today. Now, back to the episode.
Well, the administration route is the first critical variable. Getting an infusion of cells into a vein, like an IV drip, is a fundamentally different biological event than getting a localized injection directly into a specific joint.
I actually want to try another analogy here for the listener. Think about watering your backyard.
Okay, let's hear it.
If I take a massive barrel of water and just dump it all at once, directly onto the roots of one single wilting tomato plant, which is basically a localized joint injection, I might drown that plant if the soil can't absorb it.
Right, that's way too much at once.
But if I take that exact same volume of water and hook it up to a slow drip irrigation system that runs across the entire lawn over several hours, which acts more like an IV infusion, that water gets dispersed systemically. It has a completely different effect.
That's spot on.
So the question you have to ask the clinic is, which delivery method does your specific condition actually require?
That is exactly the kind of critical thinking required here. And building on that, the timing of the delivery matters just as much as the route. This brings us to the treatment schedule.
The schedule, okay.
Yeah, the source references a 2019 trial, also by Matas, that looks specifically at timing. It demonstrated that getting 40 million cells delivered in one single massive injection is not biologically equivalent to getting 20 million cells given twice, spaced 6 months apart. Wait, but the math is exactly the same there. 20 plus 20 equals 40. Why would the body care if it gets it all on a Tuesday or split up over a year?
Because regenerative cells act less like physical building blocks and more like chemical factories. This is called the paracrine effect.
The paracrine effect.
Right. Stem cells release signaling factors, proteins and cytokines that act like signal flares, and they instruct your body's own resident cells to wake up and start repairing tissue.
So they are the project managers, not the bricklayers.
Exactly. And those project managers don't survive in the joint forever. Their signal flares eventually burn out. The 2019 study found that the repeated dosing, spacing it out over 6 months, was superior to the single massive dose.
Because it keeps the project going. Yes. The first dose initiates a healing cascade. And just as that biological momentum starts to slow down months later, the second dose arrives, sending a fresh wave of signal flares to re-stimulate the process.
Wow, which proves this is really about biological strategy, not just raw payload.
Precisely.
And that leads to a really delicate distinction this source brings up: regeneration versus relief. Because a lot of high-dose marketing heavily implies that a bigger number automatically equals brand new physical cartilage magically growing back.
That is a very dangerous leap of logic that patients really need to be aware of. The 2026 AWAD Systematic Review looked closely at this distinction. They evaluated whether feeling better structurally equated to being healed.
And what did they find?
They found that while MSC therapies did provide modest, sometimes really meaningful pain relief, feeling better is not a proxy for structural physical repair.
Meaning the pain goes away, but the joint hasn't necessarily grown a new shock absorber.
Right. The repeated dose Matas trial found the exact same thing. The patients had significant clinical improvements in how they felt, less pain, better function.
That's great, but
their MRI scores, the actual structural images of their cartilage thickness, did not show significant differences. Pain relief does not automatically equal structural cartilage regeneration.
that is such a vital distinction for setting expectations. Just because the dashboard warning light turns off doesn't mean you suddenly have a brand new engine under the hood.
Exactly.
So armed with all of this, understanding viability, hypoxia, the therapeutic window, administration routes, the paracrine effect, how does a patient actually apply this in the real world?
Right.
When you were looking at 2 highly polished clinic proposals, what is your next move?
You have to systematically look past the headline numbers, and the source provides a brilliant comparative example that illustrates exactly how to do this.
Okay, walk us through it.
Imagine you are evaluating 2 proposals. Protocol A offers you 30 million MSCs. It involves 4 separate treatments injected locally into the problem area, and the clinic explicitly discloses their viability and potency metrics.
Okay, got it.
Now look at Protocol B. It offers you 100 million MSCs. It is one single IV infusion, that is the entire program, and their viability testing is entirely unclear or hidden.
I mean, to the uninformed consumer, Protocol B looks like the clear winner, right? It's 100 million. It is a massive number.
It looks like value, sure. But apply the biological realities we just discussed. Protocol A is 30 million cells per treatment across 4 spaced out treatments. That is actually 120 million total cells over time.
Oh, wow. Yeah.
Right? It uses a targeted administration route directly to the injured tissue. It uses a spaced out schedule to maximize the paracrine signaling effect, and they actually prove the cells are alive before they treat you.
Well, Protocol B might just be dumping a massive payload of mostly dead cellular debris into your bloodstream all at once, just hoping for the best.
Exactly.
Which is why the STEMCIERGE protocol comparison tool is such a critical asset here.
It truly is. The guide we've been referencing today isn't just an article. It includes this free interactive tool designed specifically to strip away the marketing.
And how does it work?
It doesn't provide medical advice, but it forces you to input the exact variables we just discussed. You enter the advertised cell count, the biological source, the administration route, the schedule, and whatever viability data the clinic provided.
And when you run the comparison, it analytically exposes the gaps. It highlights exactly what critical information the clinic is failing to provide, and it gives you the specific targeted questions you need to ask during your consultation.
Yeah, it's incredibly empowering.
And for those feeling a little overwhelmed, the guide also notes they offer a quick 3-minute quiz that actually matches you with vetted global clinics that operate with this level of transparency.
If we connect this to the bigger picture, what this tool really accomplishes is a shift in the power dynamic. It forces clinics to justify their clinical rationale. It stops them from simply using a massive number as a shiny distraction, and it requires them to actually explain the underlying biology and evidence supporting their protocol.
It demands that they treat you like an educated patient rather than a passive consumer. Which really brings us to the end of our deep dive today. Let's synthesize everything we've uncovered.
Sounds good.
We have learned that there is no universal, magic, optimal number of stem cells. The consumer instinct that more is always better is a persistent marketing myth. A cellular dose must have a clinical rationale supported by evidence, clear characterization of viability, and a delivery strategy tailored to the specific environment of your injury.
We've explored the biological realities of the therapeutic window too. Blindly chasing the maximum payload is not just a waste of financial resources. Overwhelming a closed environment like a joint capsule can trigger hypoxia, cell death, and active inflammatory harm.
So what does this all mean for you? It means your days of being swayed by the biggest number on a glossy brochure are officially over. When a clinic confidently tells you, we will give you 100 million cells, your response isn't awe.
Yeah.
Your response is, okay, what is the viability? What is the delivery route? What is the dosing schedule? And what specific human data proves that this massive payload won't just suffocate in my joint capsule?
I want to leave you with a final thought to mull over. Right now, segments of the regenerative medicine industry rely heavily on a numerical arms race, competing fiercely over who can advertise the absolute biggest cell count.
Yeah, we see it everywhere.
But as more patients educate themselves on these biological realities, and as tools like the STEMCIERGE comparison tool become the standard first step for patients, how will the landscape of this entire industry transform?
That's a great question. You now have the biological framework and the analytical tools to protect yourself. Keep asking the hard questions, keep demanding the data, and most importantly, keep exploring.
Thank you for listening. If you found this episode valuable, please leave us a 5-star rating and review, then share it with someone who may benefit from it. For global insights and personalized guidance on stem cell therapy, visit STEMCIERGE.com to receive your tailored assessment and explore your treatment options with clarity and confidence. And as always, remember, this podcast is for educational purposes only and is not a substitute for professional medical advice. Please consult your doctor before making decisions about your health. Until next time, stay informed, stay empowered with STEMCIERGE.com.